Good afternoon, good morning to my little talk about observability with Consul Connect. Let me first introduce myself. I used to go to university to become a molecular biologist, but I generated so much data there that I had to do some statistics or bioinformatics. I was so much better at that I dropped generating the data. And that's why my colleague said I sold my soul to the dark side and I became a full-time dev. In an academic world, when you're a dev, you're also the server guy. So I had to teach myself some operations. And I got quite good at this. So I finally got hired as the CTO of a little consultancy and hosting company called Hot Potatoes here in The Hague in the Netherlands. Before we can directly drop into service meshes and observability, we should discuss or introduce how we got to the two service meshes. So what will follow is a small, hopefully not too biased introduction to scaling applications. Originally, back in the days, if you wanted to do bigger, better jobs on your computer, you would have to basically get a bigger computer. In those days, that meant having to get approval, get a purchase order, wait for the stuff to be delivered on a truck somewhere. And then most of the time it would fill an actual room. And so if you wanted to make that bigger, rooms can only grow as much as the building itself. So after that, we got into horizontal scaling. So basically trying to cut up your problems into smaller pieces so that we could run it on more than 1, 5, 10, 20 computers of the same size. And therefore, we could split our problems into something that's manageable. We'd still have the same slow build out phase. You would have to get your purchase order. You would have to wait for the stuff to come from China. You have to rack it and stack it. But it was workable. No longer, you were no longer physically limited by how big you could make something. It was basically how much stuff you could fit together. After that, the internet happened and then stuff got a lot faster. Imagine you now have a web shop on the internet somewhere and you need to be able to cope with the Black Friday and Christmas rush. That meant if you're still in this slow purchase cycle where you have to basically have the entire capacity for Black Friday in your data center well before Black Friday actually happens because it's such a slow cycle. So what you you need to buy it way in advance. And basically most of the year, your capacity is not used. So you're burning your money, it's economically unfriendly. And the way then we would use to fix those problems was sticking a load balance in front. So it would look like one entry point, but it would be multiple servers. But you'd still have most of the year, you'd be burning money for nothing because you only really need the capacity once, twice, a couple of times a year. And then the internet sped up even more. Then the whole notion of service discovery was introduced. Basically, the downside to a load balance cluster is that the cluster has a vanity URL, a known URL. And if you know the magic word, you can access it. That was fine when stuff was moving slow-ish, but now there's another speed was added. So you can add a lot more services than basically the accounting could take care of. So we would have to find a way to automatically account for new services or new services going away, new instances of services coming and going. And the fine people at HashiCorp have introduced a tool called Consul that has a registry that you can query. And you can even, and it's a fairly simple DSL. It uses HCL, so the HashiCorp configuration language. And this is an example where I build out my little service, my counting service, and it lives on local port 9003. And I define a check. Basically, there's an health endpoint. And if that provides me with a HTTP 200, we're all good. And then the service gets marked healthy in Consul, and then it can get advertised around. Consul also provides a DNS server, so I can do a local dig to my local Consul server at port 8600 to my little counting service, and Consul uses a DNS convention there of name.servers.consul. You can even push it into your local bind server, where you can basically define a zone console, and you say anything that ends at .consul, I forward into my local Consul cluster, and therefore it's immediately available in your normal DNS server, and you can approach those services as you wish. Then Kubernetes got invented, or other services, but the Kubernetes is the most well-known one. And then basically the amount of services exploded, and services using other services was basically, it exploded. So we need to have another notion of what's on top of services go, and that's what we call service meshes. And that's basically where we also need to start thinking about, can a service use another service, or should it be allowed to use another service? How does that look in Consul speak? Basically, you add a little stanza that is of the connect stanza here in the middle, just below my port. I say I define its connect. I'm calling it a service, a sidecar service. Basically, it wraps around itself around my little counting service, and it tells Consul that it's available. And that's all we need to do now. All of a sudden, my counting service is Consul connected, and it's part of the service mesh. How can I now connect from another service into my counting service, and then my service dashboard on port 9002 can connect to the counting service by adding a similar connect stanza. But now instead of, then now we define the upstreams in the proxy and basically say, I want to connect to a service called counting, and please bind it to my local port 5000. And why that's interesting or useful, we'll address in the next couple of slides. Then we basically need to fire up the connections. When you define it, doesn't actually start yet. So we need to have two commands on the command line, basically Consul connect proxy for a sidecar called counting, and pipe all my logs into a log file, which we will be picking up later on. Why do we want to add complexity to something that was fairly simple? As I mentioned, there's two things. Now we can have what Consul calls intentions. We can say, you can set up Consul connect in such a way that it can deny any connection outright. And then I have to explicitly write down or configure an intention that certain services are allowed to use other services. Because most of the time when we put new services in place or new things in place, we copy and paste from somewhere else, and then mistakes happen. And that server all of a sudden becomes part of your production cluster, or heaven forbid the other way around, your production cluster all of a sudden starts connecting to your development database, and you're royally screwed. So please don't do that. And the other thing was I mentioned is connecting to a local port. So Consul is fairly cool, where it announces itself into DNS. I can easily find it, but it doesn't actually announce the port. There's ways to find it out, but it's much easier to basically say bind to my local port 5000, although the upstream is on a completely different port. But to me, it will look like I can connect to localhost 5000, and then everything else is magically taken care of by Consul. Having said that, magic scares me. I've carried a pager for more than a decade now, and magic is brilliant when it works, and it's scary when it doesn't. So we need to find a way to look into the magic. Can we still work out what's going on and how it's going on? So when we have a problem, can we look into what's going on? And for that, there's three pillars we want to look at: metrics, traces, and logs. Metrics speaks for itself, it's a number. So do we still see enough connections going on? Logs, how many errors do we see? What kind of errors are we seeing? And traces is basically how much time putting it down in very simple words, but it's basically how much time do you spend in certain areas of the application or even the platform. And now in the next couple of slides, I would like to dig a bit deeper into how we can expose these three things in basically the magic bits of Consul Connect. So how can we dig those sticks? How can we put those things in the forefront? Luckily, the awesome people at HashiCorp, when they built their service mesh, they didn't reinvent the wheel, but they basically built on another great tool called Envoy. So when I say, can we expose the stuff from Consul, we're actually really starting to discuss, can we expose those numbers or those logs or those traces from Envoy all the way to the user. So through Consul to the user. We'll start with the metrics. We'll investigate how we can use a tool called Prometheus. At the moment, to me, that's the pretty much the golden standard. It's the CNCF, the Cloud Native Foundation approved project, and it can do loads and loads of metrics. It has exporters, it can scrape. There's ways of pushing data to it. And how do we expose our metrics to Prometheus? So Prometheus, as I said, likes to scrape stuff. So it comes to you and it collects data. So it's if you remember the connect stanza we've seen before for our accounting service, the only little thing that we need to add is 3 lines, basically a config stanza that says, expose my and expose my Envoy Prometheus data on a local port, in this case, quadruple 8. And that way we can now, I should say, now this way we can expose it in every service, but then we need to basically have an agreement that all the people that write these services need to add it in themselves. We can actually force this on every service as well, so that we don't forget. So what we're looking now at is the general Consul configuration. There's actually 2 things that we need to do: is enable the central service config, and that's basically how you push central configuration onto every service. And then the config entries, where we basically say, while bootstrapping, every proxy should have a certain set of defaults, and in this case, it should have a config, and it should expose on my local port of quadruple 8. And while you're at it, please also expose the metrics for Consul itself, and that's a 4-line blob of telemetry. Then you can not only view your service meshes, but you also have Consul itself. How do we collect those? And this is 2 ways of doing it. One is the top half, the yellowish one. You say we scrape every 15 seconds, and we actually have a named list of servers we can go through. And so if you add another one, you need to add an entry here. And the simpler way is Prometheus can actually use Consul to work out which services it needs to check or which endpoints it needs to scrape. And that's the little blob in gray. And that's where we basically say, go into, use a Consul SSD config, go into my local host 8500 and find any service that is marked Consul Connect Envoy. And then it automatically scrapes all the services it finds. In Consul 1.9, actually, the UI was improved a little bit, so we can actually already see some metrics, basic metrics of what's going on in the UI itself. For that, you need to add a little bit more config, blob of UI underscore config. You need to enable it. You need to tell it it's Prometheus. That potentially you can basically write any provider yourself, but we're using Prometheus in this case. And then we basically pointed to the URL where it's be able to find. In my case, Prometheus is also a Consul service. And we specify the port. And what does it look like if you go into the UI, if you go into the services? In this case, I have a little product API that needs to connect to a database, and we can see how much queries there is. So we can do a little exploratory usage already. So we can see is stuff going on. If this drops away, then we know we have a connection issue. This is not great. It will give you an indication if some goes wrong, but we would like to use more dashboarding, more elaborate ways of looking into the data. So what I'll be introducing is Grafana, which is to me the golden standard for dashboarding, making graphs. It's open source from the great people of Grafana, and it pretty much installs on any operating system I know of. What does it look like when we want to connect Grafana to our Prometheus? And it's fairly simple. It's a bit of YAML of type Prometheus. We pointed again at the same console service. To me, I have no auth. It's when you do this for real, you probably have. But this is the simplest way. And what will it look like? This is a simple dashboard you can find at Grafana. They also have a cool service where you can share or download pre-shared dashboards, and this one is a similar one where it looks metrics for Consul. So we can see this, who's the leader, how many nodes are in the cluster, how well the cluster is performing. That's pretty much a couple of clicks away. And you can build your own dashboards on top of that, but it's good to know that you have a starting point. For logs, I will be using Loki, which is a newish tool for curating logs. So far, I've been using Elk or Splunk, but those are huge applications or platforms even in and of itself to keep running. So Loki is much simpler, although you can build it out in a microservices kind of way, but it's a single binary, which runs all the services, or if you want to spread the load out, you can actually build it out. But they advertise themselves as Prometheus, but for logs. To me, it's a much simpler way. This is, we'll next investigate how that works. If you're running in a container-only platform, it's fairly easy to install a Docker plugin of Grafana Loki Docker driver, and then we can basically push all logs directly from your container jobs into to Loki. And that's the lower half of the page. You can basically see how I would start the Prometheus cluster in a container, and the last 4 lines show that I immediately push all my data into Loki. The downside is I lose local observability, but I gain central observability. If you're not running in containers, or you wish not to lose your local observability, there's a way of pushing your logs directly into a local file and then having them picked up by a tool called promtail, which is the CLI tool that's accompanying Loki. As I said before, when you start your Consul Connect Envoy sidecar, pipe it into a log file, and there's a simpler way of basically directly integrating. Instead of piping it to a file, you can actually directly configure Envoy, the underlying Envoy, and in this case, it's the -- separator. And Consul knows everything that comes after -- is an Envoy setting. So you can basically configure anything that you would be able to configure in Envoy, you can configure directly in Envoy through Consul. And then we need to set up a little config, and it looks surprisingly familiar when people understand Prometheus, and that's because they borrowed the configuration file. So when you can write Prometheus script files, you can write promtail script files. In this case, I scrape any log file that lives in varlog and ends at proxy.log. How do I import this into Grafana? Simple again, type Loki, point it at my local Loki service. In my case, still lives in Consul. And then I can make dashboards, but also I can go into Grafana, which now has a little explore function that I can do wildcard queries. I can see the logs, I can see the spread. And that way you can start to feel familiar with what's going on, and then you can build out to dashboards. then brings us to traces. So how is my time usage distributed? In a single application, you should be fairly able to file grind the application or other ways to do it. But if you're distributed, it starts to become hard. So traces was invented, and the awesome guys at Grafana basically recently came out with a tool called Tempo, and it built on their knowledge gained in Grafana, Prometheus, Loki, and it's a much simpler way of doing things as compared to Zipkin or Jaeger, the tools that became before that required huge databases, again, Elasticsearch to be run. And this is similar setup as Loki, single binary, which you could build out into microservices. Having said that, tracing isn't, it's integrated into Envoy. The integration into Envoy tracing into Consul isn't the best, but you can do it. So what you basically need to do is you need to add another blob into your config. One that says my expose my traces as a Zipkin format, which is a well-known format that Loki, Tempo supports. And it basically will say, start pushing into something called API v1 span. And then another bigger blob that will need to be copy and pasted basically, where you can, it's quite deep JSON blob where you basically tell where your Zipkin or your in my case Tempo is, and Tempo exposes the Zipkin ports. So for Zipkin enabled applications, they can switch over to Tempo very, very easily. Again, how do we add it to Grafana? Simple YAML type Tempo into and point it to my Consul service. Can't be easier. We need to extend the Loki data source a little bit now because we want to correlate between logs and traces. So we add the little blob at the bottom, the JSON data blob, and we basically say, find in my log files something that looks like a trace ID and correlate that to build a link for me that looks into Tempo for the specific trace ID, so we can link the two things. So what does that look like? If you're doing exploratory searches in Grafana, you drill into a log entry that you're interested in, and then basically what you see at the bottom, all of a sudden a Tempo button appears. Click the button and you'll see the trace that you're interested in, or the linked trace. And then that brings to the end of my talk. Now, hopefully, I've shown you that you can correlate data directly from Envoy all the way to your dashboarding. So you can look into the magic a little bit. If you want to discuss this a bit more, I'm available at email or Twitter, and my slides will be available on SlideShare. Thank you very much.